Hello, everyone. Uh, nice to meet you all today here. Thanks for coming. My today's tech talk will be about PySpark deployment on EMR serverless, about some strategies, options, and what did we choose at Foursquare and why it's important for us to do the things in this way. A short agenda for today. First of all, we'll talk a bit about Spark in general. What is this technology about and how do we use this at Foursquare? Then I'll talk a bit about EMR and EMR serverless, just what are those services about and how do we use them. Then we'll go to the main part of this talk. It's about packaging and deployment PySpark applications on EMR serverless. And then I'll give a bit of advices how to avoid some errors when you develop your PySpark applications. So first of all, Spark overview. As official documentation says, Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning workloads on single machines or clusters. I would say that it's a very powerful and de facto standard for performing really heavy workloads in terms of data. That is work that is used across the industry these days. What Spark level, high-level Spark APIs exist? Basically, there are 5 of them, and I'm talking about programming languages that you can use to interact with Spark. It's Scala, Python, and SQL, and we use 3 of them at Foursquare, and also it's Java and R. We are not using them at Foursquare at all, or for very, very specific use cases. So I'm going to skip them today. A bit about Spark at Foursquare. Scala Spark. As Scala is a native language for Spark in general, and it's our main language at Foursquare, even outside of data engineering, a lot of our Spark applications are written in Scala because it's like native for Spark, as I said earlier, and very easy for any engineers to work on since they have good knowledge of Scala. And there are 2 more reasons for choosing Scala as a main language. Because initially PySpark didn't have all the features that Scala Spark had. And earlier versions of PySpark implementations were much slower than Scala, so we chose Scala. But we have certain workloads when we have to use PySpark in order to achieve like certain performance. And basically these are Pandas UDFs and Pandas on Spark APIs that are available only on PySpark. And also we use PySpark when we have to apply some machine learning models that are written outside of Spark infrastructure, I mean, outside of MLlib. And SQL Spark API at Foursquare. We use it widely for analytic purposes and performing some ad hoc queries just to check data, verify some hypotheses. But we don't use this for development purposes because of 2 reasons. The first one, it's very difficult to write unit tests for it. And the second one, not each algorithm can be easily implemented in SQL. Now let's talk a bit about EMR and EMR serverless. These are 2 Amazon services. And EMR stands for Elastic MapReduce. So they allow you to run your Spark applications in the cloud. And typical workflow for EMR looks as follows. First of all, you should define configuration for a cluster, which will run your Spark application. And you have to determine like all hardware requirements which will serve your needs. So you should define a configuration, then you should request cluster with that configuration and wait for provisioning and bootstrapping of that cluster. And normally it takes like about 15 minutes, maybe 10, maybe 20, but it's like in the order of 15 minutes. Then you do simple 2 steps. You're submitting your job to existing cluster and waiting until it completes. And the last step, which is really important, you have to terminate your cluster and ensure that all the resources are freed, released. Otherwise, you will be really surprised when you see your bills in the end of the month. How this looks for EMR serverless? EMR serverless offers an opportunity to worry less about configuration stuff and focus on writing your applications. So you have to create application, and here you obviously have to configure something, but it's very high-level configuration. You can choose architecture. For example, should it be x86 or ARM based? machines, and you can configure resource upper limits. So let's say that I'm not going to use more than 5 terabytes of RAM, and that's it. And then you can just submit your jobs, and you can use the same application for submitting multiple jobs. And those, it's important that those jobs can require a different amount of resources, and EMR Serverless will adjust resources that needs for the particular job. And then you just wait for your job completion and get results. Now let's move to the main part of the talk. It's packaging and deployment. I'm going just to show the idea how can we submit jobs to EMR. And I'm going to talk about more like CLI stuff, but obviously everything can be automated through your orchestration system like Airflow, and all your build steps can be automated through build system that you choose. Here we can see a typical AWS start job run command. And the first part of this job is basically your organization, department, or whatever configuration. You should specify profile which you're going to use, application ID, which you can create ahead of time, and some roles that will be used during runtime. And we're going to focus on the part which starts from job driver, and it's basically another format. How can we write general Spark submit command that comes from the past? So first of all, let me show how things works in Scala. Why it's important? It's important because, as I said earlier, it's our main language for writing Spark applications. And we wanted it made to as easy as possible for any engineers to write PySpark applications if they need, and make this transition as seamless as possible. So when we have our application, basically we have some kind of artifact bundle with our application, and we have to provide dependencies for this application, which are like third-party libraries or whatever you need. And for Scala, you have basically two main strategies. You can create an Uber jar. This means you can pack all your dependencies in the same jar and just submit this. And then you just specify the entry point for your application. But this requirement, this approach implies that you will pull in all the dependencies for each job, and you will have like a lot of those artifacts that are really heavy, and you can't share those dependencies between several applications that requires the same runtime. So the second approach is to use thin jar that contains only your application code. And you still have to provide your dependencies in some way. The first one is to provide those dependencies as separate jars, which we can do with Spark.jars configuration option. Or we can create an image with all required dependencies installed and just tell EMR Serverless to use that image as runtime when we create application, and then we can just submit our thin jar with only application stuff. Based on that, we decided that our PySpark application submitting and deployment process should use 3 artifacts or 3 bundles. The first one is Spark application bundle. This is supposed to be a zip archive with your job-related code, and it serves the same purpose as thin jar in Scala world. The second artifact or bundle is runtime environment, and this archive has packaged all third-party dependencies that you need for your application. And the second step, and it's PySpark specific, entry point for PySpark should be a .py script. So it's supposed to be just a general entry point script for any PySpark application across the company, and it's not supposed to do a lot of job. And having those 3 artifacts, how can we submit our PySpark job? We can do this in this way. If we just want to provide our thin zip with application, and we can specify the entry point for that application. But if we want to provide custom runtime with dependencies or custom Python versions, which I'll touch a bit later, we can do the following. We can just provide a separate archive and override 3 environment variables just to point to that runtime that we provided for our application. A few words about entry point script. It's supposed to be a common entry point for all applications, PySpark applications across the company. And basically, it performs 2 main actions. The first one, it loads a specified class or module that contains your PySpark job, and it calls this job entry point with all command line arguments that you provide when you submit your job. The next thing is application bundle. And we provide this by using Spark submit PyFiles configuration option. And basically, this is a zip file that just packages your code in the archive. It shouldn't contain any third-party dependencies because they will be provided as a third artifact. And an important thing that this archive should preserve the same structure as you have in your source code tree, so that each package, each model is available with the same import name. A few words about a runtime bundle, and we submit this as a Spark archive, which we specify to unzip in some folder in the working directory. This bundle contains isolated Python environment with all third-party dependencies. By third-party dependencies, I mean like everything that we install with pip or any other package manager that you use. And for the job which we submit, we can tell EMR Serverless and this application to use runtime that we provide in this archive in this way. And the great thing with this approach that we can create that isolated environment with copy of Python binaries, and this allows us to overwrite Python version that is used for this application. How can we create that runtime bundle? Basically, we have to use Amazon Linux 2 as base image, like operation system, if we can say so about images, to build this. Why do we need to use Docker? Because we have to get the same layout of all system files, all configurations as we will have at runtime. And the process includes just 4 steps. First one, we should use Amazon Linux 2 as a base image. Then we will create a venv, which is virtual environment for Python. And here is some kind of pseudocode which gives an idea how you can do this. And the main thing that you can just copy binaries, a Python binary system from the system to that environment, so that you will have all Python set up during runtime. Then you can use your requirements.txt or whatever configuration file to provide your dependencies and install them inside that environment. And then you just pack all that setup in target archive, which you will use later to provide for your job. And now I'm going to talk about several advices and maybe best practices. The first one is regarding Python versions. First of all, EMR Serverless supports EMR releases starting from EMR 6.6.0, and it uses Python 3.7, which is pretty old. And if you write some new application which uses new features, you'll probably want to upgrade your Python runtime, and this approach allows you to do that. The latest EMR release, I guess, is 7.0.0, but I've seen that 7.1.0 is out, and it uses Python 3.9 as a base Python version. So as I said earlier, with this approach, you can overwrite either upgrade or downgrade Python version on runtime. When you need to downgrade a version, for example, if you have some legacy jobs which you want to migrate on a modern architecture, you can use EMR release like 7 something, and then you can just downgrade your Python version to 3.8, for example, or 3.7 if you need. The second thing is that we should be really careful about matching Spark and PySpark versions. So as I said earlier, each EMR release has certain version of Spark installed. And ideally, PySpark version that you use for your application should match target EMR release Spark version. But what will happen if we don't satisfy this requirement? If those versions are different, we can get some errors that are really difficult to detect and understand what's happening. And let me give you an example of such errors. First of all, it's important to understand that PySpark is not a complete implementation of Spark from scratch. It's just an interface layer that uses Py4j to communicate with real Spark engine, which runs on JVM. And it might happen that your test environment has isolated sandboxes for running your tests. And this will pull in Spark version that corresponds to PySpark version that you specified. And your test will run in that isolated sandbox, and you won't catch any errors like with your unit tests or integrational tests that you run. But when you submit that job on EMR Serverless, you will use that Spark version that is installed on EMR, and it's it's not recommended to overwrite that version. And in this case, you will get Spark and PySpark version mismatch. And this can happen. This can cause like different errors, and you can track, you can catch them only on running your actual job or in production, which is not a desired thing to do. And I guess that's it from my end for today. Thank you so much. And before moving to questions, just let me give a quick advertisement. We are hiring at Foursquare. We have open positions available here. And also we have an open role within my team, the team I'm working on. And primarily we are responsible for ensuring the consistency and accessibility of major company use data sets, and that each customer within our company can easily retrieve them using like different access patterns. And primarily we're working on like a lot of data pipelines and Spark jobs. Thank you so much.
Thank you, Vlada. Any questions?
Yeah.
Thank you.
And can you talk a bit more about like price comparison between EMR serverless and like a default EMR version where you manage the cluster yourself? Like, I assume EMR serverless should be a bit more expensive for the same amount of work it perform, or not? Or you probably did some experiments on it.
Yeah, it's an interesting topic to discuss. The cost savings from using EMR serverless may not come from the fact that EMR serverless is cheaper. You can think about it in this way. When you provide your EMR or like regular EMR cluster, you have to specify configuration, and your job might underutilize those resources. And also you pay for the time while this cluster is being provisioned. And in this case, you just have to pay for whole resources, the whole set of resources which you use like for the whole runtime. And if you underutilize them, you pay extra. With EMR serverless, you pay only for those resources that are being utilized for the job, and only for that time when your job is running. So, and if someone has ever tried to adjust resource configuration for your job, you probably don't have a great idea on how to approach this job or this task. Like, it's not an obvious solution, and you'll probably always have some overhead.
Thank you, Vlada. Any more? There is one here.
You provided great details about like packaging and getting all the exact code to run. And just to understand, as a person who didn't have much practice with serverless EMR installations, how is the data handled? So are you like paying for getting the data to the compute node, or is it like keeping the data in the cluster and you're just paying for this like executables who are doing some process, some ETL?
I got it.
Is there some problems or caveats here, so that should be looked at when you're thinking about using that serverless approach?
Yeah, I would say there are no problems, but it's about like different things. So the first of all, in like big data systems, you have different layers, different like pieces of your system. The first one is a storage layer, which if you use AWS architecture, you can store your like data files on S3 or like whatever. Spark is in-memory processing engine. So obviously you have to pull in your data to the cluster and load it to your random access memory, to your RAM, to be available during runtime. And like by default, Spark under the hood uses HDFS to store like some temporary files and all that stuff. So all your data that is present on S3, first of all, will be loaded to that HDFS and then to the RAM.
Do I pay for that in Amazon's ecosystem?
Yeah, you will pay for S3 storage.
Okay, like
you will probably
reading and writing the usual, like
yeah,
the same.
And you pay for this.
So yeah,
obviously.
but basically what I'm gambling around is, am I running my own compute nodes, or do I give Amazon the ability to like fire up and send it down with the serverless approach?
Serverless approach is just another client-facing service which you can use to submit your jobs, but internally it uses like the same compute nodes, almost the same compute nodes, and it provides us just more facilities and more like flexibility for you to focus on your job and care, just don't worry about configuring and all that stuff. But basically, everything is pretty similar with regular EMR or like whatever. If you have your data layer and you have your compute layer, you will pay for both, and you will probably pay for transferring data between them, and you will have I/O. Like you can't avoid this anyway.
Yeah, great. Thank you very much. It's clear. Thank you.
Thank you. There is one here.
Maybe I missed, but what about scheduling? Can I schedule regular run of jobs?
Yeah, definitely. In this talk, I just covered the part how you can submit those jobs. But basically, you don't run your jobs once when you're a data engineer. You create pipelines out of like multiple jobs that should go in a certain order and should be scheduled. And you can use different orchestration systems. You can use Airflow, for example, or like a pretty old one like Luigi, just to schedule the jobs and run them in a certain order, just to check that upstream data is ready if it's written by another system, and you can handle this within the same pipeline.
Great. One more here.
Yeah. And any downsides for using EMR serverless? I mean, coming from Google world, I assume that Dataproc, which is analog, serverless analog, cannot use packaged like third-party stuff, and serverless can. So any cases when I cannot use EMR serverless? Or I shouldn't?
Yeah, to be honest, I haven't run into issues like this. First of all, we decided to provide our third-party dependencies for our jobs as an archive because it's like pretty close to the Scala world. But right now we're working on migrating everything to images so that we provide full runtime as an image, and then we can submit our thin application, jar or zip, like whatever, and it will use the dependencies that we purposefully provide before. So, and it allows a lot of flexibility in terms of how you can provide those dependencies. Basically, you can just put everything in the single script, and this will work. It's a bad approach, but this will work. You can provide like as an archive, you can provide as an image, and as it's based on like commonly used technologies like Docker and like pip in pip package managers, I don't see any caveats that you can provide like certain dependencies. It might happen that you should modify your some system files, system installation in order to install your package, because some Python packages require certain system-wide packages to be installed, but you can do this in your Docker file.
Thanks. It was very interesting. I have a tiny little question. When we spoke about the serverless solution, it sounded like each instance of job requires running, starting, and maintaining the dedicated instance of a Docker container, right? And it sounds like if it involves some overhead on the starting each time, does it is it even problem at all? Does it require some more dense packing of code into the job, so the starting stage is performed more rarely, or is it not problem at all? Thanks.
Yeah, basically that image is not running on a single node or a single machine. Spark is for heavy workloads. It's obviously distributed way of transforming your data, and it runs on the cluster. So you use that node on multiple instances, multiple machines, or like right now, almost no solutions running on a bare metal solutions. They run on containers, on container environments, and they can be orchestrated through Kubernetes or whatever, and put provisioning with like specified image, which is pre-built and like has don't have a lot of like dependencies to pull in and install on runtime. It's pretty fast.
There is one more here.
Hello. Yeah, I just wanted to ask you about, for example, we know that, of course, we can run PySpark on EMR, but we can also run PySpark on Glue. And we can also use like Glue workflows and access Spark on the Glue and stuff like that. So do you at Foursquare, do you use Glue and if you use it, when do you use it, and if not, why not? You can also package your stuff in jars and zips, and basically provide everything to the Spark that you need. So.
Basically, I've seen that Glue is used for some purposes, but it's very rare use. And like within our team and teams that we are working like closely with, we're not using Glue at all. So all our jobs are like primarily on EMR, but right now we're migrating to EMR serverless. So that means our new workloads on EMR serverless like from the beginning, and we're migrating legacy ones as well. But probably Glue is not an infrastructure. It's just a way how you run your job, and you have provision your infrastructure for running that as well. And it can be like whatever. It can be bare metal instances. It can be Kubernetes cluster, and you will pay for them. And basically, yeah, obviously you can a lot of options how you can run your jobs.
No more questions. Thank you, Vlado. This was great.
Thank you so much.